what's the issue we face using ChatGPT, like giving more and more prompts and all those things. Anyone? So, so like I tell my story, like for example, if you give like a lot of prompts like GPT 5 or 4 or models, like they have a limitations. Either you have they have prompt limits. Either you go for like a little lower version, or like you go for a new chat. And secondly, if you go for any other LLMs like Copilot and all those things, so they have token limits. You can't maximize your questions and queries. So like, so this was her main motto. So like, I was an intern there at Fossey IIT Bombay. So I talked to them, to the people, since because most of the softwares are now providing AI assistant. Like you can see in Flipkart, Amazon. So most of them are AI assistant because most of the people cannot do always customer support. So from there we got the idea. Why not we make an bot for eSIM also? But we have a constraints also because using bots and all those things require API servers, LLM tokens, and all those things, which really cost a lot. Like even for GPT 500, it costs $5 per 1,000 requests or so. So that was our first constant. Second constant, eSIM is an open source. Fossey and all those softwares we made, it's made to be accessible for all the people. So that was also a concern. So why offline? So we have categorized into three parts: the cost, use, and benefits. So first, unreliable internet access. So as you can see the heading, unreliable internet. So though people say like internet is not available, but still internet is not available everywhere. For example, if you go to some remote areas and if you do chat GPT search, it will not work. It will give very slow response. So this many users, especially in rural educational setups, face inconsistent connectivity. Second was data privacy concerns. For example, if you're working on some research projects or some research or you are writing some journals, so it's your work, it's your project. So you don't want to be like transparent to any other service because even if you're giving chat gpt your questions, your answer, your information, it's somewhere it's getting trained and your information getting stored. Even like Sam Altman also said, don't share your own responses or own personal information. It's getting stored and can be now used for legal purposes. So that was another reason, like separate design errors may contain sensitive research that should not be uploaded textually. And thirdly, which I mentioned, cost of cloud dependency. Relying on internet APIs increase cost and increase dependence on third-party providers, which is like somewhat not good. So, what is the use? So, first of all, it fixes your errors. Second, it is so suitable for classroom and lab. So, basically, eSIM is more targeted towards colleges which don't have access to proprietary tools like Cadence, AutoCAD, and all those things. So, that was a concern. And third, the built-in help and guide. So you don't need to go again for documentation, why it is not working, or how it should be simulated, and all these things. Thirdly, benefits. More people can use it since it's an open source. You don't need to have or make an account, log in, and all those things. You just install the software, start using it. Equal access. Students from all backgrounds can use the same high-quality tools without needing fast internet or extra resources. And since it is not dependent on internet, it performs or gives a stable performance. So here are the technical aspects which we have still used these days. How it is being made, like the GUI, language, LLM model, RAG, intelligent system libraries. Like we will come in this later part. So before giving you the idea what we are doing, so here are the some general terms. Like there have been more terms, but these are the basic terms. Like we are using RAG, retrieval augmented generation. What it is combines document retrieval with language model generation, and why used to reduce hallucination. Second, vector databases, and third is embedding. So, what is embedding is that, for example, you give your prompts in textual form. For example, if I say, "What is your name?" So, what is your name? Every is a like this is a string literal in form of tokens. So that string literal is getting converted to numbers. It is called a vectorization embedding. and those numbers are being stored in the vector databases. Using those databases, it then retrieves information and stores in that particular manner. And then there's a background like re-ranking and all those like chain of thoughts and all those concepts. Error classifications, what type of errors you're facing? Is it like a general error, is it a technical error, or you are just querying things? Secondly, rule-based system, if else things. So, so this is the schematic diagram. This is the rack. So, as I mentioned in the earlier slide, the rack. So this is the general workflow of rack, and this is the embedding and chunking. So, what is embedding and chunking? So, embedding, I told you, like it's been storing in the form of numbers. And what is chunking? So, what is chunking is that, for example, you upload your PDFs or your files. So, what it is doing, it is breaking all those big files, data resources, vector databases into small, small pieces. And then it is, oh, I think it's getting loosed. So, sorry for the inconvenience. So, as what I'm saying, the chunking process. So, it breaks all data forms into small pieces, makes it into a form. The technical term is indexing. So, makes it into a form so that the system can understand, the AI architecture can able to reduce the information which has been stored there, and then it is being again detected back to it. Now we come to the RAG. How is it working? So there's been the knowledge database in which it has been stored with various types of information like documentations, GitHub reports, profiles, reports. So website link, video link. So it has been like a pool of knowledge. So what is it? For example, when a user queries a question, when it gives a prompt. So how did this even work? So first the query is being broken into small, small pieces in the form of string literals. Then there is an intent machine which categorizes like what the user's intent is, what it is trying to search. Then it goes for the retrieval part, search in knowledge base, and according to the most semantic search or the most relevant information which has been found in that, it again goes back to the LLM where the actual response is being generated along with the information which is being gathered there, and again it gives back as a common generated text response back to the user. So this is the like basic RAG workflow, like how it is being worked. So now coming back, like what is our bot is doing, like the eSIM offline. So here are some of the features which is listed here, and this is a simple workflow, like a schematic diagram. So what our model is doing, what there is a pre-processing there because, for example, if you are uploading the data or the system at that time, so there needs to be some pre-processing. In that, there is image analysis, voice to text conversions. In the post processing, there is a markdown formatting. There is a text to speech conversion. There is a non-statistical layer like knowledge base, embedding condition, vector-based retrieval. You can give your information from there. So this is that caching layer, user input, user output layer, and for the management, we are using 22.5 model along with data integration. So these are the components and the. So first of all, we are using large language model 2.5. So the reason of using 2.5 parameter model is because using LLM on the local services needs to have a good specs computers, like good CPU, good GPUs. Even if I run like Llama 3.0 or like Llama 2.1 indexes, so it at least needs 6 GB of RAM of running those models. So, and secondly, you can't control the hallucination part also. You need to do the refining part of those things. So, 2.5 will be used because it is light source, it detects into intent, and along with that, it gives and it is local inference friendly. Multimodal data integration, user input layer, textual queries accepts users input in natural language. There's been multiple languages. For now, we have only included English and Hindi. But in further updates, we will roll out more language support. Circuit diagram uploads, the schematic diagrams, user output, what user will get, textual responses, voice output, visual feedback, text to speech conversion. This is the pre-processing layer, OCR text extraction, image voice to text conversion. This is like local knowledge base, data generation, like which I have told you about how to install the numbers, vector vectors, and charts caching. You don't have to like go for a new chat. You can go to the history, just like GPT. Go for this information which are being shared there, and then again you can continue your search. So this is the user workflow, like how it is being working there, like you can see there. So first, the user makes the diagram on the eSIM. What is that? There is a file watcher. File watcher, what is that? Whenever you draw any circuit diagram on the software, so it generates some logs, some output, some data. So it parses those data, makes it into its own version. It combines with the visual analysis. For example, the schematic editor, it is being generated there. Compares with the knowledge base, retrieval base, then composer creates query, how it is being created, what is being the use of it, and then goes to the LLM, generates the response, and then displays response. I can show the video. Then you will get a better idea. I think the net is not working. Net. Hmm? So here's a small demo, like what I'm trying to explain. So here I have made a defaulty circuit diagram in the eSIM. This is the eSIM interface, and here's the bot. I have named it Ally bot. So here I have wrote, tell me about the errors in the circuit, and now my bot is working there. So you can see it is searching. So now it is being created here. So the response is being created in a like systematic manner. Why, where is the error happening? Why is it happening? What are the reasons of happening? What improvement you can do, and all those things. So you can see these are the responses. And the most important thing, there is no limitation. You can use like endless time, anytime, anywhere, and it almost gives the exact support of chat GPT kind of thing. So I hope I'm able to like let you clear what it is happening and like what we are trying to do and what we are trying to achieve. So like, so yeah, this was the thing. What a chatbot is capable of: answering circuit-related theory queries from basic resistor capacitor questions into more advanced transistor biasing issues. Second, interpreting simulation logs. Third, guiding parameter adjustment, what you can do to better your results and all those things. Suggesting debug steps, for example, if you have encountered any error in your process of making or training yourself, you can go for that also. Recommending component selection, explaining simulation results, detecting common design mistakes, and finally providing educational insights. Offers theoretical background on concepts such as RC time constant, biasing conditions linked to the user circuit. So it's more kind of agentic kind of thing. It's more oriented to your user's perspective in domain of electronic circuit designing. So yeah, this is was the thing. Debugging scenarios, debugging session analysis or error, you can save the session also. You can share that also in backend also because it's all been saved in the form of JSON format. So you can like extract it from there also. So this is the FAQ section. For example, if you wanted to know about eSIM and all those things, or just wanted to query the documentation part, so you can go there and find those things also. And this is the live demonstration, how it is being worked there. Yeah, yeah. So here we have another demo of how it's working here, the FAQ section.
This section.
So these are like our future development goals. So like sir will elaborate more.
Yeah, so these are the future development goals which we are thinking, like the core AIML foundation. So build various data sets for our model. Then domain specific intelligence, so treating RTL code separately, then the PCB designing tasks separately, and having domain specific intelligence in that way, and scalable and adaptive AI integration. So optimizing based on our models and for low end devices like so many people don't have good devices even now like 8 GB RAM or 16 GB RAM. So to have so our model should even work for low end devices of 4 GB RAM or maybe in future scale we can go for tablets and mobile phone devices as well. Now, model data and model enhancement so these are like so debugging and verification, deployment and integration. So the similar things. Yes, so to contact us, these are our websites, fossy.in and esim.in. And so we sit at the Aero NX building at IIT Bombay. And yeah, so do visit us. And as we told, this project is under Ministry of Education. So please feel free to contribute to our project. You can write to us on our mail IDs. And yeah, so we are happy to be helped and to help. So yeah, thank you. So any questions? Any questions or such? Yeah.
Do you plan on making an agent?
Hmm?
Do you plan on making an agent?
Yeah, we are on the back and that work only.
Yeah.
Sorry if I missed this, but what are the minimum system requirements for this to be running alongside the DE?
So it's now actually in under development it's in beta phase, but for this it's like minimum 4 GB now. Like for nowadays minimum systems are coming with at least 6 GB of RAM. So we are focusing on more lower part. That's why we are tweaking and all those modeling and refining the LLM parts.
4 GB specifically for the LLM or total 4 GB?
Total.
Total.
Total 4 GB.
Total 4G.
Any more questions?
Any more questions related to fellowships, internships?
Yeah.
This model actually interacting with the electronic components.
Uh-huh.
So yeah, what it is doing is that, as I mentioned, whenever you are making those diagrams in the schematic editor, so there is been back end the information being generated. Like for example, the netlist file, the keycats files, those log files. So it is using those data. Along with that, it is if I can show you. No. This one. So what it is doing, in the back of the server, it is for example, if I am putting these sub circuits, so back of it is being generated all those data. If you are connecting the wire, it is being getting those outputs of it. So using those output along with the image analysis, it is being doing here. It is combining both the data and then it is giving the answers. So it is combining both the visual and the textual part and then it is giving the response.
Question is when you use the model, which type of data you use, like supervised or unsupervised? I mean, you are giving the image, but when you give, so we need
No,
to
it's
check individual components.
Since we are using the RAG, so it's kind of supervised along with reinforcement learning. Because we are giving the data, so you have to be particular in those data, to reduce the hallucination parts. So we have more kind of a specific kind of thing. Like for example, in this body, if you write who is the wife of Salman Khan, it will not answer those questions. So that's why.
And you use LLMs, but this is specifically for electronic component. Why you instead of using LLM, why don't you write SLMs?
Why?
Why should you not directly divide the data particularly using particular components for different tools are used and for different.
Yeah, I get it. But how will you reduce the errors? You are segregating the errors. But how you will know that okay, this is the error, you have to do this, you have to do that.
So, but when you use that is better, it's quite 4 GB as you say, and it also
Yeah. No, sir, also, yeah, that's what I'm saying. We are watching with the caching and cache issue. So right now we are working on that thing also, try to minimize the use of the RAM and the CPU usage. So based on that thing, even if it runs on the minimum of system requirements, can give the answers and the responses.
so but SLM don't be a better approach.
What? SLM, small LLM model. Small. Yeah, I have used those also, small LLMs, 1.3 billion parameters. I as
So it's even lesser amount of payment.
see, it all depends on. We can use that also, but the problem is when you go for lesser and lesser billion parameters, the answers tend to get deviated. And first of all, those things. Second, the chunk sizes also, which you are making of those, the prompt, the text window, it all gets limited. So you have to take like a sweet point. Like my work can be done this thing and this thing. So like a balance. So that's why we like opt for point to point.
Is it possible we can interact with multiple SLMs instead of using LLM? Like you make SLMs and then for individual person that he can directly download the package that for his use.
But I can't get it.
I mean, is like you are using a fast and my idea is if you make the small SLMs and if you आपको
Next question is, instead of using a single big LLM, why didn't we use small multiple small LLM?
material small LLMs or just for required SLM required SLM इस पे आंसर करना ऐसा
So you mean to say like multi-agent? Multi-agent. Yeah, multi-agent can be done, but since what I've said, resource constraint. So for running those multi-agent, you need like a hefty system, like good GPUs and all this. And since we are running those models on locally and tracking those things like multi-agentic rack is successful where you are using directly API sources. For example, if you take Grok, Gemini, ChatGPT, and then merging all those things. So what you do like segregated, like if it comes to general question, you go to Gemini. If it is technical, you go to GPT and all this. So there your point comes to. I hope I am able to answer.
There was a question, how did you get the data? Now, where is the data stored?
So the data is the per time for the development is being stored in the local part in our local server.
How much space does
How much space? Uh, Currently, it's like we have been segregating to small chunk parts also, like zip files also. So it's now, I guess, 10 GB, I guess. But still, we are like increasing more data.
because obviously there will be some this part of
So that's where the chunking process comes in. So we are like, it's like a brute force kind of thing. It's like we do a test part, like for example, we are making the chunk like 200 and all those things. Token size window is like around 5,000 we have given. So that way we are like, so like that way we are taking those results. So that our main purpose is like it's able to reduce the process. So that's it.
Okay. Yeah, thank you.
Thank you everyone.
बट मैं यहाँ पे नोट्स तो आ ही नहीं रहे।
अभी तक स्पीकर में चाहिए
हम लोग कुछ प्रिपेयर करके थोड़ी हम पढ़ के मिलेंगे, तो फिर वहीं से
ऐसे हो जाए ये स्पीकर नोट्स नहीं है ना, मुझे उसी से करना स्पीकर नोट्स चाहिए।
तो फिर इसको कैसे बंद करूँ?
क्या तो स्क्रीन शेयर कर सकते हो? तो मैं चेंज करती रहूँगी और उससे अपने डाटा से ये वाला क्या है प्रेजेंट कर
आ रहा है?
नोट्स नहीं आ रहा है, देखो नोट्स दिख रहा है।
हाँ, वो मेरा अलग से आएगा।
स्क्रीन शेयर कुछ तो
अबे यार, स्क्रीन शेयर
दोनों डिवाइस में होगा।
हो रहा है ना? हम्म, आ रहा है ना? ठीक है। स्टार्ट कर सकता हूँ?
Hi everyone, I am Hardik Chandral and I'm here to talk about Agent Torch today. So Agent Torch is currently an agent-based simulation framework which is being developed by MIT Media Lab, and I am an open source contributor over there. So just a brief overview first. So there are many grand and huge challenges like climate change and pandemic like the COVID-19, which emerge from complex interactions of millions of individual decisions. So how the COVID-19
hello. Okay, how the COVID-19 actually spread is not, you cannot really create a simple one-to-one mapping between an individual and how the COVID-19 spread. It is actually a result of millions of people interacting together in an environment and taking decisions based on which this kind of disease spreads. So while LLMs and AI agents can excel at imitating individual behaviors of a particular environment or a particular individual, they cannot model these intricate societal dynamics. They cannot actually, simulate how a person interacts with his or her environment and takes decisions because of the state or the current things happening in the environment. So that is why we are developing large population models. So this is basically a new AI paradigm which simulates millions of interacting agents simultaneously and captures collected behaviors at societal scale. So it actually simulates, let's say, millions of agents or people in a given environment and exactly captures how they interact with their environment and how why and how these environment factors lead them to taking different decisions. So what is actually Agent Torch? Agent Torch is basically an open source framework which helps in building these large population models and running these massive simulations. So it's optimized for GPUs. So you can actually simulate these simulations parallelly on various different GPUs, and which helps you to capture how these different individuals actually interact within an environment. So for an analogy, you can basically understand that Agent Torch is an analogous version of PyTorch, but made for more large-scale agent-based simulations. So some design principles about Agent Torch. First is scalability. So Agent Torch can actually simulate country-size populations in seconds on commodity hardware. So you can actually simulate how people in a city, let's say in New York City, will actually interact within an environment, specifying some constraints over their movements or some environment within your laptops. Differentiability. So agent torch models can differentiate through simulations with stochastic dynamics. So this actually enables gradient based learning, and this can actually help you to calibrate your model and find the most optimum version of it. Next is composition. So agent torch models can compose with deep neural network architectures like the LLMs. So agent within agent torch, you can specify a different agent to be a different LLM, which can actually then interact with a lot of different agents and take decisions. The last is generalization. So Agent Torch helps simulate diverse ecosystems, humans in geospatial worlds, or cells in anatomical worlds, or autonomous avatars in digital worlds. If you would go to the Agent Torch website, you can find numerous examples of various different simulations being taking place within the framework. So you can head over to github.com/agenttorch, or you can directly pip install AgentTorch to understand how the framework works and read about the underlying code. So it is very simple to get started with Agent Talk. You just need a 3 line of code. So you need to import the environment. So we have a lot of predefined environments already created, and import the model and the population which you want to simulate. So for example, here I have imported the mod populations.boston. So it is actually going to simulate the Boston city. And then you can we also provide various visualization functions as well. So it actually helps you render a kind of a GIF, so that you can understand how different agents will be moving in the environment and taking decisions. So Agent Torch has had a large impact throughout the world. So we have the New Zealand government is actually using large population models and Agent Torch to simulate during the pandemic how people will be requiring the COVID-19 vaccines, and how the demand will change throughout the nation. It is also being used in India uh, to simulate the solar power energy requirement, and how people in different rural areas might get benefits from solar energy. It is also being used in the USA to simulate the supply chain of the US markets and see how goods are actually flowing within the market. So I particularly worked upon this differentiable discrete sampling using Agent Torch framework. So I extended Agent Torch to this particular use case. So currently the problem was that discrete sampling poses significant challenge in gradient-based optimization due to its non-differentiable nature. So discrete samples are actually non-continuous. So you cannot differentiate through discrete timestamps. You need a continuous timestamp through it. This actually prevents effective backpropagation, and you cannot actually optimize your model if in case you have discrete samples. So there was a technique known as Gumbel softmax technique, which is currently the thing which is kind of the sorter technique for this differentiable discrete sampling. So it addresses this by using a reparameterization trick that adds Gumbel noise to the logic and applies a temperature control softmax. I've kept the maths out of it so that everyone can appreciate this thing. And this enables differentiable approximation of discrete samples. But Gumbel's softmax has its own limitations. So if you would look upon the mathematical formulation, it actually, the temperature parameter, which I talked about earlier, introduces a bias variance trade-off within this equation. So what it essentially does is that if we have a higher temperature, this leads to much more continuous samples, and which create it, and through which you get a smoother gradients. But this actually deviates from the two categorical, in the sense that you get a more uniform distribution rather than a particular categorical distribution. While if you go for lower temperatures, it would actually lead to near discrete samples, and it will be very difficult to uh, differentiate through these near discrete samples, and will ultimately lead to unstable gradients. So, as I talked about earlier, its continuous approximations may require straight-through estimators, which can introduce bias during backpropagation and might lead to unfavorable results. So we introduced a new method for discrete sampling. We created this particular categorical class, which actually helps solve this issue and provides a differentiable approximation to discrete sampling, and helps us deal with this bias variance trade-off. So we did a lot of experiments using this categorical class which we implemented, and to see how our estimator actually performs against the Gumbel softmax technique. So the first one was the random walk experiment. So what we did over here is that we simulated a Markovian random walk. What a Markovian random walk is that, let's say you are a particular position xn, then you can move towards right with a probability e raised to the power minus xn by p, where xn is your current position and p it can be the range of values your position can take. And you can go towards left with a probability of 1 minus e raised to the power minus xn by p, which is just subtracted by 1. So what we tried to do was we introduced the parameter theta within this probability distribution function. So the experiment actually focused on optimizing this parameter theta, which was embedded in the exponential probability distribution, which you can see over here, e raised to the power minus x plus theta by p. And we targeted, what we wanted was we get the most optimum value of theta, such that the random walk which we simulate is very close to our baseline. So how did we get this baseline was, we did the same thing but with a binomial distribution. So we got a baseline, and then we trained this the value of theta on, let's say, 70% of the baseline, so that we optimize the value of theta and get a value of theta such that the random walk which we sampled with our estimator is very close to the baseline. So let's look at the results. So these were the results. The red one depicts the Gumbel softmax technique. So you can clearly see the Gumbel softmax shooting far away from the baseline, which is depicted in these dashed black lines. Whereas our method, the categorical blue one, was very close to the baseline and performed way much better than the Gumbel softmax technique. Another experiment which we did was the Boyd's model. So what Boyd's is, it is an artificial life simulation originally developed by Craig Reynolds. So the aim of the simulation is to replicate the behavior of flocks of birds. So during the season of spring, mostly birds migrate from the north to south. So they do not, migrate in a very haphazard manner. They migrate in a kind of flocking behavior, wherein these birds tend to move in flocks together, and they do not, while they are moving, they do not actually collide with each other. So what Boyd's model did was to replicate this kind of behavior, so that different Boyds or different agents within the environment can move together in a imitating a flocking behavior kind of thing. So what Boyd's model introduced was, instead of controlling the interactions of the entire flock, it created a set of rules for each and individual Boyd or a bird within the flocking, within the group of the birds, so that following those rules, the birds will eventually come together and move in a group without colliding with each other. So the rules which define this behavior were that, first of all, was separation. So what separation means, that each bird attempts to maintain a reasonable amount of distance between itself and the nearby birds to prevent overcrowding. The second is alignment. So birds try to change their position so that it corresponds with the average alignment to other nearby birds. So you can basically understand this alignment behavior as that each and every bird tries to align its velocity vector with the average velocity vector of the whole group, so as to align together, basically move in a similar direction. And the third one is cohesion, which means that every bird attempts to move towards the average position of the nearby birds. So this is kind of basically calculated by getting the centroid value of the flock, and then each and every bird or Boyd in the flock tries to move towards that centroid position, so that all of them move together in a flocking manner. So the results were that these results were for Gumbel softmax technique. So you can clearly see that different points are being represented by these blue dots are spread throughout the environment. And in some regions we saw flocking behavior, but key point to note over here that the velocity vectors were haphazard; they were not aligned together. Voids were tending to move in different directions, and also some voids had a low velocity while some voids had a very high velocity. So this is not actually truly imitating the flocking behavior which we wished for. Whereas the categorical class which we wrote in the agent torch framework, you can clearly see that the results are way much better than what we saw in the London softmax technique. So you can clearly see the voids tending to come together in small flocks, and their average velocity vector is aligned in a same direction as the other velocity vectors, and the average velocity is also way lesser than the Gumbel softmax technique, which shows that this is a more stable simulation and depicts much more flocking behavior than the Gumbel softmax technique. We are also working upon another technique, which we have named as the fixed adaptive uncertainty gating, which actually shows much better versions than categorical here. But I have not included this in presentation since there was a time constraint for me. We also did a lot of other experiments, which I was not able to put in the slide due to time constraints. But we saw similar performances that the categorical distribution, which actually imitates the stochastic AD. If has anyone heard about stochastic AD over here? So stochastic AD is stochastic automatic differentiability. It is a forward automated differentiability paradigm, which is currently the SOTA method for this kind of behaviors. And we have modeled a categorical distribution similar to the stochastic AD method. So this was all which I had to present. If you guys have any questions.
In this, if the velocity is not considered, so the part which is it is backwards and having high velocity, so it's having any element, it will collide.
Sorry, did not understand.
The part with having high velocity and with if it is given any alignment, but it is below the part which is having low velocity, so it will collide on it. If we don't consider the velocity of the part.
No, we are considering the velocity of the birds over here. So as I talked about earlier, these three rules. So the reward function which we have, modulated, it takes account all three behaviors, and it starts giving preference to one if, let's say, if the cohesion reward goes down and these both are up, then we have modeled the reward function such that the weight of this cohesion reward will go up, and the simulation will give preference to cohesion and will want the flock to, include much to become more cohesive during its simulation. So that is what we are wanting. That is being taken care by the reward function. You mean that if a void has a lower velocity and the upper void has a higher velocity, then they might collide? That is a learnable behavior. They will collide in one episode, then the parameter will change. Then the second episode they might not collide. So initially they will, but the system slowly learns and then decides the optimum weights to be given to all of these three behaviors.
Will you show some more environments that we all have provided, and what is the process to create an environment process?
So I talked about this earlier. You can head over to this link. Over there you can find a lot of environments. So we have environment for New York City, we have environment for Boston, and we have environment for COVID-19 simulations as well. We have environments for wherein we have simulated predator prey environments within forest. So you can, and it is very simple to even create an environment for a custom environment which you want to simulate. Sorry? I have not included the code snippet over there, but I think you can check out the GitHub repository. The detailed documentation is present over there. If you want to import a population which we have already created within the framework, you can follow these 3 lines of code, the 3 simple steps, and you can execute your simulation. Any other questions? All right, thank you guys. You can head over to this link and you will find the Slack link to our group wherein you can join and feel free to contribute if you feel you can add on to anything. Thank you. ये end कर दो.
हाँ आप लीव कर दीजिए.